Welcome back, everyone. Today we're going to discuss some more examples of using the limit definition of derivative to calculate this derivative function f prime of x. Alright, so here's our function for our first example. We've got f of x is 2 over x minus 3. We want to calculate f prime of x. So we're going to take 2 points. Again, remember, we'll take x and f of x. And then we will take x plus h, and then f of x plus h. Okay, so we've written down our 2 points. Nothing I can really do to simplify this, unfortunately, so I'm going to leave it just like that. So I'll calculate the average rate of change between these two things. So that will be 2 over x plus h minus 3 minus 2 over x minus 3. All divided by h. Okay, I'll go ahead and write that as 1 over h times, and I need to put these things over a common denominator. And note, because these denominators are different, this one has an h, this one doesn't, I'm just going to need to multiply them together. And so my common denominator is going to be this mess. Okay, and so this will be 2 times x minus 3 minus 2 times x plus h minus 3. Okay, and we're going to continue simplifying this. Okay, so this will be 2x minus 6 minus 2x minus 2h, and then plus 6, all divided by x plus h minus 3 times x minus 3. Okay, and we hope there's a lot of cancellation, and there is indeed a lot of cancellation. So there's a 2x and a minus 2x, and a minus 6 and a plus 6. And so I'm going to get just 1 over h times minus 2h divided by this product. And this h now cancels with that h. And remember, that was my goal the whole time, was to get that to happen. And so this is now minus 2 divided by x plus h minus 3 times x minus 3. And so that gives us our simplified average rate of change. So then finally, in order to calculate f prime of x, we just take the limit as h goes to 0 of our answer. And because we've done a good job simplifying, this now simplifies pretty nicely. And so this is going to be minus 2 divided by x minus 3 times x minus 3, which I could probably write as minus 2 divided by x minus 3 squared. Let me also do one that involves square roots. Okay, so I'll write down my points. Bump that point a little to the right, so we get x plus h, then the square root of, and it's going to be 2 times x plus h, so that's going to be 2x plus 2h plus 3. Okay, this in here came from the fact that I got 2 times x plus h. So now we have our 2 points, so we can write down our average rate of change. And that is going to be square root of 2x plus 2h plus 3 minus the square root of 2x plus 3, all divided by h. So just as with our previous radical questions, the thing we want to do is multiply by the conjugate. So namely, we want to multiply by the same thing except with this minus being a plus. So I'm going to multiply by 2x plus 2h plus 3 plus the radical 2x plus 3. And remember, I have to divide by the same thing because I'm not trying to change the thing that I have here. I only want to multiply by 1. And so now, when I multiply this out, it looks like it's going to be horrible, but it's actually not going to be too bad, because I'm going to get this square root times itself. So that's going to give me 2x plus 2h plus 3 minus this square root times itself, which is going to be minus 2x minus 3. Okay. And remember, we get this really complicated cross term where I have this square root times the other square root. But that pair gives me a plus, and then that pair gives me a minus of exactly the same thing. So in fact, my whole numerator ends up being this. Everything else disappears. Okay, and so now I've got an h times 2x plus 2h plus 3 plus the square root of 2x plus 3. Okay, so now my numerator simplifies quite a bit. There's a plus 2x and a minus 2x, and a plus 3 and a minus 3. And so there'll be a 2h left in the numerator, divided by h times this whole mess. And note this h cancels with that h. Now I've gotten my h canceled, so I have my average rate of change. And so then I can calculate, okay, f prime of x is the limit as h goes to 0 of now this thing. 2 divided by the square root of 2x plus 2h plus 3 plus the square root of 2x plus 3. And so what is this going to be? Well, it is going to be 2 divided by the square root of, and so this 2h is going to disappear. Okay, and so that is 2 divided by twice the square root of 2x plus 3. But now the 2's cancel, and so the final answer here for our derivative is 1 over the square root of 2x plus 3. That is my f prime. Okay, so there's one more type of question that shows up in this section. This type of question is going to come with a graph. Namely, I've got here a graph of a function, 1 over square root of x. That's my f of x. That's this curve. I've picked 2 points on here, 1, 1, and 9, a third. Those are both really on the graph. I've drawn in the tangent lines at those 2 points. And really what this question asks is, hey, where do those tangent lines intersect? That's the whole question. So to figure this out, I need to find the equation of both of these tangent lines, and then set them equal to each other, and then I'll have this. Okay. But before I can figure out the equation of these tangent lines, I need to calculate the derivative. And I have 2 choices of how I could do this. I could calculate both f prime of 1 and f prime of 9, the way we did in section 3.2. Or I could calculate f prime of x, the way we've been doing in this section, and then plug in 1 and 9. So if I use method A, then in order to solve this question, I'm going to have to do 2 of these, find the average rate of change between the 2 points, and then take a limit things. Here I only have to do 1. Okay. So the option I recommend when you're doing these questions is to choose option B, to calculate f prime of x and then plug the stuff in. Okay. But either will work. A is just more work. So if I'm going to do that, then I need to write down my 2 points, x, f of x, and the point where I bump this over just a smidge, like that. And then I calculate the average rate of change here. Okay. So as I go along, I'm going to rewrite that h just as 1 over h times, and I need to put these things over a common denominator. So that common denominator is going to unfortunately be the square root of x times the square root of x plus h, which is not the loveliest thing I've ever seen, but we'll make do. And so then this will be square root of x minus the square root of x plus h. Now what do I have to do? Well, I've got this whole square root minus something business, so I have to use my multiply by the conjugate trick again. So I'm going to multiply by the square root of x plus the square root of x plus h. divided by that same thing. So the denominator here is going to be h times the square root of x times the square root of x plus h times square root of x plus square root of x plus h. That's this thing. And then the numerator is just going to be x minus h. And the x minus h here is because I'm subtracting x plus h. And so what's that? That is minus h divided by h times the square root of x times the square root of x plus h times the square root of x plus the square root of x plus h. And that's where I get to cancel the h's. Okay. But I am not to my derivative yet. Because to actually calculate the derivative, I have to go one step further than just canceling the h out of my average rate of change. Namely, I have to take the limit as h goes to 0 of that thing, which is going to be minus 1 over the square root of x times the square root of x times twice the square root of x. It's twice the square root of x because this is a square root of x plus, and this is also going to give me a square root of x. And so my conclusion at the end of the day is that f prime of x is minus 1 over 2x to the 3 halves. Each of these x square roots of x is an x to the 1 half, so together that is x to the 3 halves. If you'd prefer, by the way, you're more than welcome to write this as minus 1 over 2x root x, which is maybe what you would be inclined to do, because this square root of x times square root of x, that's just x. I've got an extra square root of x, then I've got a 2. This is also a perfectly reasonable way to write this. Okay, so we have completed the process of doing what we called option B at the start. Now, I have to go about finding the equations of these tangent lines. So I'm going to call this line 1, and this line 2. And I'm going to go ahead and proceed to find the equations of line 1 and line 2 using this formula. So line 1, we know it passes through the point 1, 1. And then the key here is that the slope of this line is given by f prime of 1, okay? Which will be minus 1 over 2 times 1 times 1, right, which is minus a half. Which says that my equation of my line looks like y equals minus 1/2 x plus b. Reminder, I need to actually plug this 1 into my formula in order to get the slope. This quantity itself is not the slope. This is the slope. So now I can go about finding my b, so I can go ahead and plug in the point 1, 1. And so that gives me that b is 3 halves. So the equation of line 1 is minus 1/2 x plus 3 halves. I need to do the same thing for line 2. Line 2 has the point 9 1/3. And then its slope is going to be given by f prime of 9, which is minus 1 over 2 times 9 times 3 by our formula. Is minus 1 over, and that looks like 54. So the equation of my line here looks like y equals minus 1/54 x plus b. We can again plug in our point. 1/54 times 9, that is minus a sixth. And so b is 1/6 plus a third, which in fact is 2/6 plus 1/6, which is in fact a half. And so, just to record this up here, because I'm out of space to do it other places, the equation of this tangent line is y equals minus 1/54 x plus 1/2. Okay, so that's line 1. This is line 2. Now, I want to point out, these answers both agree to a reasonable degree with my graph from before. So both of these lines have negative slopes in the graph. This line, line 1, has a steeper slope. Minus 1/2 would be steeper than minus 1/54. They both have a positive y-intercept. Matches. And the y-intercept of line 1 is bigger than the y-intercept of line 2. Great. All of that lines up. And so now, what is the question asking? Well, I have an equation for line 1. I have an equation for line 2. The question's now just asking for where those things intersect. And at this point, because all I want is the intersection of these two lines, I can more or less forget every other piece of information I knew. So I can forget about this function, it's not going to be used anymore. I can forget about this derivative, it's not going to be used anymore. I'm just now going to use these two equations. And as always, the way I'm going to go about this is I'm going to set these two equations equal to each other. Now, I don't really want to deal with all of these fractions, so I'm going to multiply through by 54, which is going to clear out all of my denominators. Okay, so when I multiply this minus a half by 54, it's going to give me a minus 27x, plus this is going to give me a 3 times 27, which is 81. This is going to be just minus x, plus, and then this is going to be plus 27. So I'll move the 27 over to here. 81 minus 27, that'll be 54. And I'll move the minus 27 over here, so this will give me a 26x. And so this will give me that my x-coordinate is 54 over 26. Which, if you work it out, that is 27 over 13. So, in our original point that we wanted to find, our intersection, we've now found the x-coordinate. Namely, the x-coordinate is 27 over 13. How do we find the y-coordinate? Here's where it's easy to go awry. Because the thing you probably want to tell yourself is, well, just plug it in. And that's right, I do just have to plug in the 27 over 13 and it'll tell me what this is. But I have to pay close attention to where I'm going to plug this in. Okay? Because this is the point that I'm looking at. And so what's important is this point is on both lines. It is not on the graph of f. So there are three possible places that I could want to plug the 27 over 13 into. I could want to plug it into f, into line 1, or into line 2. I definitely cannot plug it into f, because that would tell me this point up here, where the x-coordinate's the same, but the y-coordinate's completely different. So don't do that. But since this point's on both line 1 and line 2, I should be able equally well to plug it into line 1 or line 2. Will make no difference. So then when I look back at these, I can choose whichever of these I happen to like. I guess I'll go with line 1. And so then when I plug in x, I'm going to get y equals minus 1/2 times 27 over 13 plus 3/2. That is going to be minus 27 over 26 plus 3/2. Okay, rewriting this as over 26, that's going to be minus 27 over 26 plus 39 over 26. So 39 minus 27 is 12. Okay, but then I can cancel a 2. So I'll get 6 over 13. Okay, and so that, at long last, is my y-coordinate. And that's the answer to this question. All right, I'm going to wrap up this video here. In the next section, which is the last section for test 4, we're going to talk about what it looks like when you graph the derivative. But that's it for now. I'll see you all next time.